I want to try and demonstrate what's done in example 2 of this module. We have the vector -1, 3, and the first thing we do is we kind of extend the line that that vector lies on. And so I can try and do it by hand. One thing I'll make sure is that it goes through this point, because to draw the original vector I went 1 to the left and up 3. So when I go 1 to the right, I ought to be going down 3 as well. And similarly with the blue vector, when I went 4 to the left, I went up 2. So when I go 4 to the right, I want to go down 2. So I'll extend the line this way. And maybe erase a little bit here. Okay. So next, what we want to do is we want to think about the vector 3, -4. And we're trying to reach that endpoint there. And so the procedure described in the book says, well, let's draw a line parallel to -1, 3 that goes through 3, -4. Remember that you can move vectors, right? You don't have to start at 0, 0. That's the standard placement. But I can go 1 to the left and up 3, and I would be here. And if I go 1 to the left and up 3, I would be here, and so on. And we can do the same idea with the blue. So again, starting at the vector at the point 3, -4, I want to move 4 to the left and up 2. So I go 4 to the left and up 2, which will put me through here, and then 4 to the left and up 2. And again, I get a line parallel to the blue vector. And so the next thing described in the module is to realize that what you have here is you have a parallelogram. And what we want to do is we want to look at the sides of the parallelogram here and here and ask, can we represent those as multiples of the red vector and the blue vector? I mean, the red vector is actually a little easier, right? This is -1, 3, and we can see that this is clearly just the same vector but the opposite direction. And so this vector here is the vector 1, -3. Or another way to think of it is it's negative of -1, 3. It's the opposite. For the blue direction, we're looking at this vector right here, and we see that it is the opposite direction, but it's actually half as long, right? So we're going to take -1/2 of -4 and 2. And so that's the vector 2, -1. And sure enough, it hits the point 2, -1. And so I guess what I can say is that 3, -4 is equal to -1/2 of -4, 2 plus -1 of -1, 3.